consciousness. That perhaps the dark components aren't simply forces or matter, but manifestations of intelligence, or something like it. This is speculative, of course. It drifts close to metaphysics, but it's not as unscientific as it sounds. If dark energy is shaping the cosmos without being measurable, if the laws of physics themselves might vary from region to region, if even the speed of light is not as constant as once thought, then perhaps we are seeing only one layer of a much deeper, more complex reality. A reality that might not be random at all. A reality that may be structured, intentionally. Hashtag the collapse of the old cosmology. These revelations do not mark the end of science, but the beginning of something new. What we are witnessing is a revolution in cosmology, not unlike the paradigm shift brought about by Copernicus, Galileo, or Einstein. For over a century, physicists have believed we were on the cusp of a complete theory of everything. But the universe, it seems, has other plans. The James Webb Space Telescope, this marvel of human ingenuity, has opened a door to a cosmos we barely recognize. A cosmos where the old rules no longer apply, where constants may be variables, where the fabric of reality itself could be alive with hidden dimensions, new forces, and perhaps purpose. Hashtag conclusion. The dawn of the unknown. It's an exhilarating and terrifying time to be a scientist, or a thinker, or simply a human being trying to understand where we come from. The James Webb Space Telescope is not just a mirror into the deep past. It is a mirror held up to our assumptions. And the reflection is strange. Maybe the universe is older, or infinite. Maybe it had no beginning, no end. Maybe dark energy and dark matter are illusions, crutches we've used to walk a little further, only to realize we don't understand the ground beneath us. And maybe, just maybe, what lies beyond our current understanding isn't chaos, but a deeper kind of order, one we're only beginning to glimpse. In the end, the more we learn, the more we realize how little we know. But that is not failure. That is science. And the journey has only just begun. The universe reconsidered, Adam Rees, James Webb, and the coming cosmological revolution. Imagine waking up one day to find out that nearly everything humanity believed about the universe, how it began, what it's made of, how it evolves, and where it's heading, might be wrong. Not in the trivial sense of a minor miscalculation or an outdated theory, but fundamentally, existentially wrong. This isn't the plot of a science fiction thriller. It's the state of modern cosmology today. Hashtag a warning from a Nobel laureate. Dr. Adam Rees, one of the most respected astrophysicists of our era, has sounded the alarm. Winner of the 2011 Nobel Prize in Physics, Rees was part of the team that made a shocking discovery at the turn of the millennium. The expansion of the universe is not slowing down, as we had long believed. It's accelerating. This unexpected revelation gave rise to the concept of dark energy, a mysterious force thought to comprise about 70% of the universe, yet completely invisible and undetectable. It was, and still is, one of the most profound mysteries in all of science. But now, more than 2 decades later, Rees and thousands of scientists around the world are once again facing a bewildering possibility. We may have misunderstood the universe itself, at its most basic level. And this time, it's the James Webb Space Telescope that's bringing the message. Hashtag the Hubble tension, a window into the unknown. The story begins with a number, one that seems simple on the surface, but carries immense implications. The Hubble constant, or the rate at which the universe is expanding. In theory, we should be able to measure this rate in 2 different ways. 1, by looking at the early universe, as seen through the cosmic microwave background, and 2, by measuring the local universe, nearby stars and galaxies, and calculating how fast they're moving away from us. If our understanding of physics is correct, these 2 numbers should match. But they don't. Rees, working with the Hubble Space Telescope, used standard candles, celestial objects with known brightness like Cepheid variables and Type Ia supernovae, to measure expansion in the nearby universe. The result? A Hubble constant of around 73 km/s/mpc. Meanwhile, measurements from the early universe, based on data from the Planck satellite, which maps the afterglow of the Big Bang, yield a much lower value, around 67 km/s/MPC. This discrepancy became known as the Hubble tension, and it's not a trivial gap. It's statistically significant, and it's getting harder and harder to dismiss as a measurement error. So who's right? That's where James Webb comes in. Hashtag James Webb confirms the tension. When the James Webb Space Telescope launched in December 2021, scientists hoped it would settle the debate once and for all. Equipped with revolutionary infrared capabilities, Webb can peer deeper into the universe's past than any telescope before it. Its precision promised to either confirm the local measurements or reveal where they went astray. But instead of resolving the conflict, Webb deepened it. Webb's measurements of Cepheid variables and supernovae matched those from Hubble. Different telescopes, different instruments, same results. Which means the discrepancy isn't a mistake. The instruments are not flawed. The data is not corrupted. The tension is real. And that means we might be wrong about the nature of the cosmos itself. Hashtag dark energy revisited. Let's rewind to the turn of the century. Rees, along with Saul Perlmutter and Brian Schmidt, discovered that the universe's expansion is speeding up. This ran counter to the long-standing assumption that gravity would gradually slow the expansion, perhaps even leading to a future big crunch. To account for this acceleration, scientists postulated a new form of energy, dark energy, an invisible pressure permeating space itself, pushing galaxies apart. Dark energy became a pillar of the lambda-CDM model, the standard model of cosmology. Along with dark matter and the cosmological constant lambda, it formed the mathematical scaffolding on which our understanding of the universe was built. But here's the problem. No one has ever directly detected dark energy or dark matter. They are inferred, useful concepts to explain observations, but not yet grounded in physical evidence. And now, thanks to James Webb, we are being forced to confront a haunting possibility. Maybe these placeholders aren't real at all. Maybe we've been trying to solve the wrong puzzle. Hashtag anomalies beyond measurement. The anomalies don't stop with the Hubble tension. Webb has shown us galaxies that formed too early, some of them just 300 million years after the Big Bang. They're massive, well-structured, and full of stars, much too evolved for the young universe. These galaxies shouldn't exist. In theory, the early universe was a chaotic, dark, and formless place, a time when matter hadn't yet condensed into stars or galaxies. But Webb shows us ancient structures that seem to defy the timeline. There is no clear sign of the dark age of the universe. It's as if cosmic evolution hit fast forward in a way that makes no sense under our current understanding. Even more troubling, observations of galaxy clusters challenge the cosmological principle, the idea that the universe is homogeneous and isotropic, meaning it looks the same in every direction. But perhaps it doesn't. Some of the vast galaxy formations Webb sees appear to violate isotropy, suggesting that the universe may have regions with different expansion rates, densities, or even physical laws. This undermines the very core of modern cosmology. Hashtag a universe with no beginning? If galaxies form too fast, if the cosmos isn't isotropic, if expansion rates vary from region to region, then maybe the Big Bang itself is in question. The Big Bang theory has always been an elegant fit. A universe that begins as a singularity, expands rapidly through cosmic inflation, then gradually cools and condenses into the stars and galaxies we observe today. It explained a lot of things, well, cosmic background radiation, redshift, the abundance of light elements. But elegance is not evidence. In fact, we've never observed the Big Bang directly. What we see is consistent with a hot, dense early universe, but not necessarily a singular point of origin. Some theorists are now proposing that the cosmos may have no beginning, that it expands and contracts in cycles, or that our visible universe is part of a much larger, eternal structure. Others suggest a radical view, that the universe is more like a fluid, with regional currents, bubbles or flows of space-time that expand at different rates depending on their surroundings. In this view, there was no bang, just an ongoing evolution of space that may have no start and no end. Hashtag the soul of the cosmos? And then there's the wildest idea of all.